Welcome everybody. This is the 2024 Codebreakers Walkthrough Challenge, Part 4 or Task 4. Welcome to everyone that's new and welcome to everyone that's continuing the series. In the last challenge, we were looking at trying to find a decryption key in the U-boot settings and found that through the environment variables. This time we have a new task with trying to emulate some firmware and see the problems that we come across there and the challenges we have to face. So first, let's read the description. We're able to distract the diverse firmware, however there isn't much visible on it. All the important software might be protected by another method. There is another disk on the USB device with an interesting file that looks to be an encrypted file system. Can you figure out how the system decrypts and mounts it? Recover the password used to decrypt it. You can emulate the device using QEMU Docker container from task 3. And it looks like we're just tasked with entering a password to decrypt the file system. And then here are our files. So let's download all of those. SD, USB, this shall be there. And we can hop in, change to our new directory. Make dir 4, change into 4. And let's move everything from downloads over here. So we have all of our files. And we should probably extract them all. Because they're all just a lot of them are bzipped right now. Guess you don't really need to for these two probably, but we're going to extract them all just to be safe. So bzip, is that installed? Yep, bzip 2, nope. Oh, it is. Nice. Think techx. Then we'll just do the DTB first. Techx. Tech-D for decompress. Looks like I decompressed it. Do the same for the other files. Oops, bzip2 tech-D for the kernel. I think this one might take the longest. Never mind. Tech-D SD. This one might take the longest. So the other one shouldn't be as bad. To USB. Perfect. Now we have all the files decrypted and we're ready to go. So DTB, we didn't look at it last challenge, but that's just a hardware to virtual memory kind of layout for QEMU to use. You can decrypt it or decompile it with DTC. We'll just do that real quick. DTC, don't remember how to run off the top of my head. I think we had to specify output and input versions. Ctech output, copy that, but we're going to change this to a DTC. Dash capital O for the format, just to specify DTS. And then I think we specify an input file with tech capital I for DTB, and then it looks like our input file is just the regular file. So BCM DTB. Run that, get a couple warnings, but it should still have compiled it, or decompiled it in this case. Got to correctly open the file. And here you can actually get the human readable memory layout stuff. Nothing too crazy or spectacular in here of note for any of these challenges. Pretty much just specifies kind of what the hardware device expects to have and what it should emulate and where it should be stored in memory. If we were to look at the kernel itself, it would probably just be a kernel image for this challenge. Looks like it's still gzipped. Nothing. We're not going to look at it because there's nothing there. But this SD file and this USB are more interesting to us for this challenge. As you can see, this one's saying it's a boot sector with partitions. They're both boot sectors actually. And when you come across memory for memory-based files or challenges, a good tool to use is called binwalk. And what this does is it goes through the file and tries to find any kind of common file archetypes or information it can find within this drive. So here we can see that within this we've found a file system, found an executable script, a path, some Lux magic, an extension file or ext file system, found an RSA key, or SSH key I guess, and some firmware header information. But you can see that nothing actually outputted, just printed out the information. What we're going to want to do is actually extract this. With this command, we're actually going to do SD first because that one takes longer. And then in a new tab, we'll just do the USB. So we can see that while those are actually going to pull out some information and put them into our system. Takes a little bit of time. The SD one's going to take a little bit longer, but we can see we now have these two new directories called extracted. And you can see we have a couple files in here. Usually the files themselves, if they've just ext, are just remnants of the file system it found. What we're really interested in is these two directories here. So let's go to root first, and we can see we found 3 files. If we just look at them, it looks like they have data in them. If we open them, we can see hostname comes up with a random string called nasty plea. If we look at mount part, it looks like we have a bash script with some arguments coming in, which we don't know because we don't know how this is running yet. It looks like it's going to echo to the screen that it's not found if it doesn't exist. Looks like we make the directory, try to mount the directory. We grab our name as our host name, so we know what the host name is, or what we're assuming the host name is just in this hostname file. Grab an ID, which is the cat of the private ID. Don't know what that is yet because we don't have a private directory. And it looks like data is now a name and then ID, and then this is bash string concatenation or string manipulation. So this is trying to grab the first three characters from the ID. And it looks like we have an echo crypt setup, opening encrypted partition, echo data, takes our data, which is this string concatenation, pipes it to, looks like SHA-1, does an awk magic, looks like it tries to get rid of any new lines. Crypt setup, open encrypted partition part, and whatever this crypt setup command is. If you don't know what that is, we might be able to see if it's installed. Looks like it is. If we do man crypt setup, I'm not sure if man, there, nice. So it looks like we're able to manage plain, DM crypt, lux, and other encrypted volumes. So it looks like it's trying to possibly pass in a password to decrypt encrypted partition. And that might make more sense. It's trying to then make a directory for the encrypted partition or encrypted mount, and then try to mount part, which appears to have been instantiated through this crypt setup. So it looks like this mount part is trying to decrypt something, and if we check out this final file, it looks like we have a LUX encrypted, and if we remember back to the man page we just checked out, this LUX encrypted part is probably what we're trying to decrypt. Looks like we're using version 1 AES, just garbage information. What's important is version 1 because there are 2 versions, but we'll come back to that in a little bit. We can check out this second directory and see that we have some more files. You can see that they all should have data in them, or what appears to be data in them. But it looks like this private key, oh, yes, I want to install XXD. XXD is just a inline hex dump, same to hex dump, but just my preference. Looks like it's just full of null bytes, so that's probably either not included or corrupted in some sense. If we check out this other file, looks like that one's there. Check out this file. So this looks to be an SSH key. We don't know what to SSH into yet or what it's even used for, so maybe it's not important to us. This id.txt looks important. And that also appears to be nulled out, though. ECC usually stands for elliptical curve cryptography. P256 is usually just the number of bits, so this looks like a 256 curve. Hopefully we don't have to deal with too much of that because crypto are in this challenge, and we'll find out we actually don't. That's for a further challenge later on. But id.txt has a similar extension to the /private/id.txt, so maybe there's a hint that this is the file we're actually looking for, but we don't actually know for sure yet. Next, we can go into the SD image, see what's in here. Looks like we have 2 directories as well. Looks like in x-root, we have a kind of looking normal file system. No hidden files off the bat except for .ssh. It doesn't look like there's anything in there though, so nothing of use yet. Linux, that looks to be empty. You could check out bin. It just looks like some regular files. Drivers. You could go through the drivers, but I'm pretty sure those are just there to help set up some of the communications for the Chemu drive, or maybe they're already on the system, because maybe decrypt looks important, but or reverse engineering those isn't of use because you just look up their names and see that they're just public uh, kernel modules that don't appear to be modified. If we look through Etsy, we can see Dropbear. Dropbear is usually an SSH client. Those should just be local keys. Doesn't really matter too much to us. fstab, hostname. I don't think hostname will have anything. I don't think fstab might. fstab has some stuff. Doesn't appear to be anything useful. Hosts. Appears our local host is set up. initd exists, but let's check out password first. Looks like there's only one user. And then DHCP, which appears to be a script to connect to DHCP. Oops, change to init. So initd might be files that are usually run at boot, and this RCS kind of has an interesting file name, so that's maybe something to note. Looks like we have a binsh script. Looks like we're trying to mount proc, mount system file system, do some memory dev, mount everything. Then we try to go through the drivers and insmod them. Make sure our hostname exists. If it doesn't, set it. Looks like we set our private IP to 10.101.255.254. We set up some ifconfig stuff. Looks like we're setting up the interfaces. Set up a UDHCP, set up Dropbear, and it looks like we're running mount part, which if we remember, mount part was the name of the bash script in the other directory. So it looks like here's our arguments. Sending SDA2, private, opt part encrypt, and then agent. So if we remember back to what those were, which I certainly don't, so I'll just go check them out. The first argument should be the secure drive, so SDA2. Secure mount should be where we're probably mounting it to. Yep. So we're going to mount the second drive to private. Then we have an encrypted partition, which part.encrypted kind of lines up with what we had saw with the Lux drive here, being part encrypt. And it looks like once it's encrypted, we're going to encrypt or send that to increment argument 4 or agent. So it looks like whatever's in this is actually going to be set to /agent, and it comes from, and everything in this secondary drive, SDA2, is probably set to private. So that's good to know. Is there anything else? Doesn't hurt to just keep taking a look. sbin, just looks like some regular files, user, bin, sbin, in there, nothing in there. Var, just var run. I don't think there's anything in here. Nope. So we can go back and go to this last directory, and doesn't look like there's anything in here either. All right, so looks like now that we know our kind of path coming in, it looks like this may be a kind of brute force setup challenge, and with cryptography, since we know what the host name is, but we don't appear to know what the ID is, and since it's only 3 characters long, it seems to be within a generous key space that's available for us to crack. But let's just test it real quick so we know that this is ran with crypt setup. Here, let's just do a quick test. So we know we can just write all of this at once, actually. I'm going to change this up a little bit. Am I in the right directory? Change here. I'm in the wrong directory. I'm just going to close that terminal. Change to this one. There we go. So we don't have encrypted part. We can just say part encrypted. And then let's just do a test to see how long it takes to run on like an average case. So we know our example is nasty plea, and then let's just add 3 characters. So we'll do AAA. I'm going to run this all within time if I can. Oh, it's not going to like that. Let's do quotes here, get rid of this quote, and then this quote. I'm not sure if time will actually work like this. Yeah, it definitely didn't like that. Oh well, we'll just have to count ourselves. So get rid of that. Get rid of this. Running as non-root. Oh, probably doesn't like the fact I'm not writing that as root. Just do a quick sudo su. It's the crypt setup part, so it's going to try and open the mount as a super user. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh. So around 12 seconds-ish. Probably counts a little bit fast. Maybe 10 seconds per attempt. Which, even though it's 3 keys, if we do some quick math on like a normal key space, so there's 24 lowercase characters, 24 uppercase characters, 52. If we add numbers, it's 62. 24 I meant 26. So 62, if we were to add symbols, it'd be even more. But then that's going to be to the factor or to the power of 3. And that kind of gets real slow real fast. So we kind of need to find a way to... We don't need to find a way to lower our character space, but it'd be very helpful. So if we go back over to our... Oops, meant to go back to the other one. And we take a gander at this id.txt, since we have a good inkling that this is going to be our file. We can see that we know the file is 36 characters. We just don't know what's in those 36 characters. We can actually do a quick Google search and just say id 36 characters length and see what shows up. The first thing that shows up is a UUID. So if you don't know what a UUID is, it's a type of universal identifier, whatever, based off a couple of factors that just generates a very unique key. And just based on this alone, there's a good chance that this is what we're probably using. And the fact that it's 36 characters long and it's an ID. Other than that, there's no real hints yet as to this being a UID, but in further challenges, this is kind of confirmed that it's a UUID. So we're going to use that in future information in this. But if you didn't know, just brute forcing off of the visible character space, while it would take a little bit of time, it is possible to complete the challenge just through that. But now we know that the character space is a UUID. This means that our character space is now made up of pretty much the hexadecimal range. So 0 to 9 and then lowercase a to f. And that makes this a lot easier, as that's only 16 characters to go through. But now we need a way to actually brute force this, because we're not going to want to do this by hand. There's actually some nifty tools out there that if you just look up Lux crypt setup brute force, see what shows up. So this one first right here, this is the one I'm going to use, brute force Lux. I'm just going to grab that link and we'll pull it down. See if we can't. We'll just do it in this directory. Do I have Git installed? I do. Nice. Git clone. Lost my space. Then we have to come in here and follow the directions on how to get this guy running. Just zoom in a little bit. Looks like we have to compile it, so we have to install a couple tools. And then we have to install libcrypt setup. Do yes. And it looks like we just do autogen, configure, and then make. So it's taking a little bit longer than I anticipated, but no worries. There we go. Autogen makes our configure script. And then we can make. And now we have the brute force Lux. So if we run this, we can see it has a couple of possibilities. Looks like we do a beginning of the string, end string, file, tag H for help, length, so minimum length, maximum length, character set, number of threads to use, print progress every n seconds. So if you were ambitious, you might just jump in here, do our beginning of the string is our host name. The character set is 0 through, or hexadecimal character range, not ASDF, 9 A, B, C, D, E, F. Length will be 12, and then maximum will be 12, because we have 9 here plus another 3. And then we might just set our threads to 4 or something, because that should have 4 cores on this. And then with the encrypted partition. Should be a backup directory. I'm in the wrong directory. Oh well. Extract part encrypted. But you'd be incorrect, because we need to remember that the mount script is using SHA-1, so we can't just send the data straight into it. We need to grab the SHA-1 hash and run against that. So we need to generate a bunch of SHA-1 hashes for this to run with. So I'm going to do this real quick in Python. A best way I can really think of is just use hashlib import SHA to SHA-1. Our character set, just do char is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. We know our host name is nasty plea. That should be that. I'm going to set these both to byte streams, because it'll be easier, because we have to pass in a byte stream to SHA-1 anyways. I wouldn't recommend doing it this way, but this is one of the easiest for x in char, for y in char, for z in char. Then we could do something like m is equal to SHA-1, m dot update hostname plus x plus y plus z. This triple nested for loop, very prestigious and very hard to understand and comprehend for those geniuses out there. And then we could do m dot, just print m dot digest, I think. I think that might come out in raw form, so I think we want hex. Try that. Concatenate bytes to hex, which makes sense. I'm just going to convert these guys to bytes then. Since that's a byte string or character, a byte array is going to grab them as individual bytes. It doesn't appear to have that .digest.hex. I don't think that's a method. I think it's a property. It is a method. There we go. So it looks like we have a bunch of hex characters now, so we can just dump this guy into our word list. And now we can run this against our word list. Did I run this yet? Nope. Tac H to figure out what the word list one is. Number of threads, we're going to want that. Looks like F. Tac F for word list. Tac T, I'm going to set this to number of threads 4. I'm going to make it verbose so we can actually watch it run for a little bit. And then we can do the correct file. Been a little bit easier if I was in the correct directory, but oh well. No, this needs a number. Let's do every 5 seconds. So every 5 seconds it should dump to the screen to say what the progress is. So it looks like within the first 5 seconds it hasn't tested anything. Second 5 seconds it tested 1. Did I set number of threads? Yeah. 4. And we can see up here at the top, this has our CPU usage. It's going 100% all the way. Not very ideal, but with enough time, this will come around to our answer. Luckily for me and for you as the viewer, we don't have to sit through it the entire way. I have a infinite knowledge of what the password might be off the top of my head. So I'm actually going to shrink this down to include just the passwords. And then, so if you didn't, since you don't know usually what the password is right away, you wouldn't be able to do this, but just to make this look more viewing pleasure, or make it look better in the viewing angle, and so I don't have to edit this video and just do it in one take, I'm just going to make the word list a lot shorter, and then we can try these passwords. And if it doesn't find it, then we'll have to do something else. Oh, look at that. Found the password. 3A977D. It doesn't appear to stop once it finds that. That could be because it's threaded. So you have to be on the lookout for that. But now we have the correct hash. Hash is equal to this. We didn't actually save the output, so we don't know which one it is, but we know that it's within this character set. So we can say if This guy, if that is equal to hash print, let's do x comma y comma z. I think those might print as decimal though. They did. We'll do bytes at x comma y comma z. Looks like it's 99e. So now we can try and extract this guy. Change to xroot. I'm just going to cat this, run this command by hand. We want the encrypted partition. Oops. Part encrypted. And then for data, we're going to send in nasty plea 99e. And then if this correctly worked, got to run that as root. So I'll just copy this and actually change back there. So this one's running as root right now. Run this, and if everything worked correctly, we should be able to correctly mount this and view the data inside. Didn't get any errors, so I'm just going to make a directory called agent, because that would be mounted as, and mount slash, what is it called? Just checking my notes real quick. Dev mapper part? Nice. So what crypt setup does is it's going to try and mount this share into dev mapper part, and then you can mount it to your or whatever directory you want through the mount command. And if we check it out, it looks like we have several new files. If we look back at what they want the password used to decrypt the file system. Now we have two possibilities. Do they want the SHA-1 or do they want the unencrypted one? Let's try the unencrypted first, because that's the actual password. But SHA-1 might be what they're looking for. Oh, looks like my session has ran out, so just had to try it again. It looks like that was it. And that should be everything for task 4. Yeah, should be just straightforward. The biggest problem people had for this challenge, I think, was just trying to get that narrow down the key space and find tools to run this, as the Lux encryption is a little bit more complicated. There's a couple different tools out there to run it. I think when I first did it, I was using Hashcat. That ran a little bit faster on my system, but I also was using a larger key space because I hadn't inferred at the time that it was a UUID, and as it was the beginning of the challenge, I knew I had time to brute force a larger key space and wasn't really concerned with a larger amount of characters to check. But yeah, thanks for watching, and hopefully continue the series.